How would you answer a question like this? Well, at GCSE, you'd probably use a method like FIFA to find the acceleration. So FIFA goes like this. We put formula, we insert values. The formula here is F equals m times a. We insert our values to try and find the acceleration, and then we figure out 60 divided by 0.2. Now, this is absolutely fine, a perfectly valid way of finding out an answer. However, is this going to be fine at A level? Well, yes, but you also need to be able to rearrange the equation. Now, by rearranging, what I mean is, before you put the numbers in, can you rearrange the letters to figure out what the subject is going to be? So in this case, the subject of the equation needs to be A, acceleration. So what I'm going to do first of all is write down the formula just to make it easy to know what I'm doing. Then I'm going to figure out what A by itself, I've got times by m, so I've got to divide by m to find out what it is. Ends up with the same equation, same answer. But at A level, you need to be much more comfortable with doing that with your algebra. Now, so we're not going to focus on FIFA for this video. We've moved on. We're going to look at something a bit different, rearranging equations. So tips before we start. Now, as you would have done stuff like this in maths, you should know that if you're changing the subject of an equation, it is really important you are consistent with doing whatever operation you're doing exactly the same to both sides. If you divide by something on both sides, you make sure you do it properly on both sides. And bear in mind, sometimes there are multiple steps to do. Take as many stages as you need. Don't get arrogant, don't get cocky, don't think you could do 3 or 4 things at once. If you need to take an extra line or 2 to figure it out, then fine, crack on. First equation we're going to look at today is the kinetic energy equation. So we're going to make V the subject of the equation, kinetic energy EK equals half mv squared. So first step, we need to get everything onto the left-hand side that's not v. So I've got half times by m times by v squared. So first thing we're going to do is get v squared by itself. So I'm going to get rid of the m and the half. So I've got to do the same things to both sides. So if I divide both sides by m, it disappears from the right and goes on the bottom of a fraction on the left, which is our first stage. So now I've got EK over m equals half v squared. So dividing is the opposite of, it should say multiplication there, it's the opposite of multiplying, so therefore I can get rid of it. I can do the same thing with a half. Now this is going to look a bit messy, but the half will go on the bottom of the fraction next to the m. Now, that's absolutely fine to write it like that. There is a neater way of writing it we'll come on to later, but I've now got EK over half m equals v squared. Now my final operation, I've taken an extra stage to do this because, like I said, take your time, is to get rid of the square. Now the opposite of squaring something is to square root something. So I do a big square root and then put my term from the left-hand side into that expression to find out what v is. Now divided by half is the same thing as timesing by 2. So that's where I'm going to make that look a little bit neat and tidier. It's not more correct, it just looks a bit better to be able to figure out my final answer in simpler terms. So square root 2ek divided by m. Now, I'm going to give some examples of your own here. Some of them from GCSE, some of them from A level. Each one you're going to have to make something the subject. Okay, so if you have got a pen and paper handy, it'd be really good if you can have a practice of this yourself first. Practice makes perfect, so then make sure you can do this for when you are doing it in the class or in an exam. So first equation is P equals I squared R from GCSE. Next one is the equation for the volume of a sphere, 4 over 3 pi r cubed. Next one is one of those Suvat equations, which comes up in year 12, S equals ut plus half at squared. And the last one is to do with simple harmonic motion, something from A level, which is t equals 2 pi and then big square root L divided by g. So pause it if you can, have a go. Right, let's figure out what these ones are then. So I squared is p over r, therefore I equals big square root p over r. That's I the subject, job done. Next one, we're trying to find r the subject. So dividing by 4 over 3 and pi will give r squared cubed by itself, cube root everything, and the same thing as dividing by 4 over 3 is timesing by 3 over 4, so I've simplified that fraction a little bit there to give me 3 over 4 v over pi. Now the third one we've got to be really careful with because we've got ut plus half at squared, so the opposite of plus is to minus, so my first term is se minus ut equals half at squared. Next I'm trying to get a by itself, so divide by a half, which is the same thing as timesing by 2, then divide by t squared. The last one is really tricky because g, I'm trying to make the subject, it's in a giant square root, so I've got to square everything to get it out with the square root, so that means t squared, 2 squared, pi squared as well, then rearrange, so I've got t squared divided by 4 pi squared equals L over G, then get G to be the subject, which means L divide by, and then put it all in the brackets, make it look neat and tidy, T squared divided by 4 pi squared. So those are 4 examples of rearranging equations. Practice makes perfect. Get as much practice as you can, so it makes it easier in class. So one of the main things of being able to do rearranging equations is you can combine equations together, which is a big thing in A-level physics, making one equation and another, kind of mish them together so you find another one. So an example of this from GCSE you might have come across is to use Newton's second law, force equals mass times acceleration, and acceleration is change in velocity divided by time, to derive a new expression for F. Now, F equals m times a. I've got a in there. Now, a is equal to change in velocity divided by time. So instead of writing acceleration, I'm going to write down change in velocity divided by time. That term separately, put in brackets so it's obvious what I've done. Next, I'm going to kind of combine those things together. So I've got m times by change in v, all divided by change in t. Now, those, if you've done the GCSE course, you should know that momentum is equal to mass times change in velocity. So, and sometimes used by the symbol p. So actually, momentum divided by time is the same thing. So therefore, we've combined the equations together. Another one we're going to look at now, this is from magnetic fields, which is usually year 2 of A-level physics, but it doesn't really matter, we're just looking at letters and algebra today. So it says show using the expressions F equals mv squared over r and F equals bqv that r equals mv over bq. So b and q do have meanings, it's all to do with particle accelerators. This equation works with circular motion, but we don't need to worry about that for the time being. But this time they give us an answer. This will happen quite a lot at A-level, but you've got to show how to get there. So because both equations have f in them, we can equate them together. We can make them equal each other. So mv squared over r equals bqv. Let's simplify it down. I've got a v on both sides, so I cancel the squared and the v on the right hand side. Next, I've got mv over r equals bq. I'm trying to find what r is, so I'm going to times it by r on the right hand side and then divide through by b and q to give me what the final answer looks like, which is what we were trying to aim for in the first place. So make sure you practice these because it's really important for A-level physics.